Welcome to EDU World Space.
Hello and welcome to Chapter 1, Problem number 33 in Physics for Scientists and Engineers with Modern Physics. So this problem tells us we have a rectangular plate here of these two lengths that I've written here, and it asks us to find the area of this rectangular plate, including the uncertainty. So how you calculate area is pretty straightforward, length times width, but how we include the uncertainty is a little bit different. What we're going to have to do is we're going to first calculate the area, not including this any uncertainty, so just this 9.8 and the 21.3, and then we're going to both add and subtract the values of the uncertainty. So and then calculate the area of those next two areas, and then we're going to see which we're going to compare those to our original very certain equation and see which one has the greater amount of difference, and that will be our total uncertainty. That's a lot to follow, so let's just jump right into it and take it step by step. So as I said, we're going to start off by calculating the area without the uncertainty. So we have 9.8 times 21.3, and that's 208.74. Okay, so this is going to be the value that we're really just going to report without the uncertainty. And it's going to be the value we compare to our next two values. So next we're going to do is calculate the area, what I call high area, the area including the addition of this uncertainty. So we're going to add that 0.1 to the 9.8, and we're going to add that 0.2 to that 21.3 here. Okay. So that'll give us, when we do this value, 9.9 times 21.5. That'll give us 212.85, okay? So what we're going to do is we're going to subtract 208.74 from this value here to give us an extra. So we'll see that we have an additional 4.11 centimeters in this high value, okay? So this is one value. This could be one of our values of our uncertainty. So the next thing we're going to do is do the opposite. We're going to subtract those decimal points, that uncertainty. So we'll do 9.7 times 21.1, okay? And so that's going to give us 204.67. And we're going to subtract this value from our original value, 208.74. And that'll give us, we'll have 4.07 less centimeters with our low estimate here. And so we're going to compare these and see the absolute value of each. And so when we do that, we'll see that the high extra of 4.11 will be more than the 4.07. So we're going to say that this is going to be our total amount of uncertainty, because we know with the original uncertainty, it could be anywhere from 208, it could be anywhere from 204.67 to 212.85. And so 4.11 will cover this second half here. So basically, we're going to say, we're going to say at the very end that we have 208.74, that original value, the original one without any uncertainty, and we're going to include the highest absolute value of the excess in our other calculations here. So since 4.11 is higher than 4.07, that will be our plus or minus value here for our uncertainty.